Right? Everybody good? All right, this is depth first search versus breadth first search, and you certainly, if you don't read XKCD, you all should because it's funny. And this one is the guy who's doing a depth first search, and he never quite manages to get out of the shower before his girlfriend comes. All right, so now we're going to do depth first search, and as I said, we're going to put it in the stack. Yeah? All right, so we start with S is found but not handled, so it's in the stack, and then we're ready to go. So what we do is we take the various nodes from S and we handle them and put them on the stack. We pop stack S out of the stack and pop those guys on the stack, right? And then it's a stack, so what happens next? We pop B and we push B's neighbors, right? And then we pop E. Oh, we would have popped E and pushed E's neighbors, but how do I feel about the resulting graph? Right? Here, this is kind of what we're doing, right? And does that feel like a depth first search? No, that's lame, right? So we want this, so this was wrong. So this is, everybody kind of follow that?
No.
Well,
So,
isn't it just in the order that they're handled, not that they're added to the stack?
well, no, because here I pushed those guys all on the stack, and already we've gone wrong because we want a path. We don't want these guys done, right? And then from here, well, we could handle these or we could handle these. This handling these would look a little bit better, but still the final picture is going to have all these guys hanging off of it, which we don't like. All right? So we want the picture to look like this. And you'll note that the difference between these two pictures is here, S has handled all its edges, while here, S has only handled its first edge, right? So we're not going to fully handle nodes, we're going to partially handle them. All right? So anyway, here's the kind of, it's a big general graph, but here's the tree that we're finding. And we're going to add these guys here have already been searched and come off the stack, right? And these guys here, same. But what's on the stack now is this black line, all right? And then we're going to search these and pop that and come down here. So these guys here have not been found. These guys have been found and handled, and what's currently on the stack is this. All right? And there's a new loop and or system invariant that we're going to maintain, which is that what's on the stack forms a path from S. Right? So you see here, what we got is a path from S, and we'll continue a path from S, and we keep doing that. What's on the stack will always be a path from S. All right, everybody buy that? So let's trace out that example. Oh, there it is. There's our path from S. And so now what we're going to store on the stack is the nodes that are partially handled. Right? We found them, and we haven't fully handled them. Maybe we haven't handled them at all. Right? But we found them, and they're not completely handled. All right? So we're going to say how many edges have been handled. So how do we start? We start by saying we found S and we've handled 0 of its edges, right? And so what we do now is we pop this off and it tells us, oh, we've handled 0 of S's edges, so what do we do next? Let's handle S's first edge, all right? So that's why then what is the first edge? It goes to A, so we push A0 on the stack, right? So we've handled 0 of A's edges, but we've handled 1 of S's edges, right? Everybody buy that? Yeah?
When S is 0, we actually pop it and then change it and then push it again. Yeah.
Yeah, I would say. I think stacks, you pop them, you change them, you put them back, right? Maybe you can get in there and change the top guy without popping and pushing it, but it boils down to the same, right? Somehow this was a 0, 1, it was a 1, 0, and you popped it, looked at it, changed it, pushed it. Everybody good? All right, so then we're going to handle the first of A, which brings us down to C. And then the first of C, which brings us to H. And the first of H to K. The first of... Oh, now what about K? It doesn't have anybody, right? So we say K has now been fully handled, and K is pushed off the stack. All right? So in our color scheme, orange, as you see, orange will be the stack, and as the tide recedes, it's going to leave, the glacier recedes, it leaves a river behind or something, right? So that's the black is where it's going to be the tree that we're building. All right? Everybody buy that? So now we see, we've handled one of H. So what do we do? Oh, there's no more. So we, here I'm just saying, this is the path from the stack, and this is a tree edge. Just what I just said. Right? And then we pop H, right? And now we've done one of C, so what do?
Go to I and change C.
We go to I. Now, from I, where do we go?
H.
Maybe we go over to H. All right? Now, I'm calling this a purple edge, and there are all these various kinds of edges. I know when Andy teaches it, there are back edges, cross edges, and forward edges. And I think there might be another one. Anyway, we're going to consider only sort of two issues. The one, well, this is a tree edge, which might be a forward edge. No, I don't know. Anyway, tree edge. This one here, the point about it is it's going to a node that's already fully handled. Right? So it's kind of cross or it's forward. Here's a couple of types, and we just don't care. Right? The point is it's going to a node that's already been handled. Everybody good? And then, right, cross, right, it's a cross edge, great, to a handled node. All right, then we go down there, it's also a cross edge. Then we go down there, and it's a new edge. So then we go across there, and it's been handled. And so then we start coming, then we go up there, and we go down there. Now, from here, I was looking the first edge coming out, and it went here. Right? A cycle. Everybody notice a cycle? So what's exciting about this edge, this one I think is called a back edge. Very back edge. What's true about it, it's going to a node that's currently on the stack. Right? And the why it creates a cycle is because the what's on the stack is a path, and then there's an edge back, which creates a cycle. Right? Everybody buying that? And if your goal in life is to look for cycles, this is a way of looking for cycles. All right? Everybody kind of follow that? Anybody not get it?
Yes, sir. What's the edges again?
The purple edges are going to things that have already been completely handled.
Okay.
Right? Well, the red edges are going to something on the stack which creates a cycle. So forms a cycle, and then from J we go down to M, and then we go there and we go up. Then we come back and we come back and we go up to F. And then we got another cycle up to S, right? And then we come back and we come back and we go. Here we keep following it. And look at all that work, right? Yeah. A. Where do you want to go back to?
Yeah, there. So were they already handled or were they just
Right, so C, we've done two of C's edges, this one, and now we're going to do that one, which is purple because it was already black. This is already black. It already has a black edge to it.
Yeah, but are A and C already handled?
A and C are on the stack, so they're partially handled. So if we found an edge, if there was an edge up to S, then that would create a cycle. Yeah. So here we're popping the stack, and now we did all this work, but and we're back to kind of where we started with, except this isn't a 0, it's a 1. And what we've done is we've reached everybody that can be reached from that first edge, right? So now what we're going to do is we're going to reach everybody we can reach from the second edge, except everybody that we reach from the first edge, we put breadcrumbs on them, right? So we're never going to revisit things, right? We're going to go back. We're going to do the same from here, except if you see things you've seen before, you stop, all right? So you go down the S's second edge, and there's going to be much less to do here because, right, we've done most of it. And now, what do we do now? Right, we've seen all of S's edges, so it gets popped off the stack and we're done. Yeah?
What was the significance of the number of edges?
Here are the number of edges.
No, yeah, what is the significance? Why are we keeping those?
Oh, it tells us how many edges that we've handled already. Right, so here, from B, if we go back to here, here we've handled 0 of B edges. Then we handle B's first edge. Then we handle B's second edge. Then we handle B's third edge. Then we're done with B, so B comes off the stack.
So we're assuming we have some sort of like hash set or something in the background to keep track of the
The order?
already visited one. Well,
Uh,
yeah, I guess.
Yeah, that it doesn't require too much. You just need a breadcrumb, just like we did before. Everyone has a node which says, has it been found? Is it on the stack? Partially handled, fully handled, right? Breadcrumbs.
But is it just like a flag in the very beginning?
Yeah, I would just put a flag. Yeah. Yeah.
So again, back to the number of edges. So we're just taking it to how many edges each vertex has, and that's about it. We're not using those number of edges.
These numbers?
Yeah.
This is how many have been handled.
But we're not using it in the code or something.
Yeah, completely we're using it in the code because here, if I'm at this point, what do? I pop the B0 off. I say I've only handled 0 of B's edges, so now I'm going to handle B's first edge. And so what's B's first edge? Well, let's call it this one. So I handle B's first edge, and I push back on the stack that I've handled B's first edge. Now I repeat. I pop this off, tells me I've handled B's first edge. So what do I do now? I handle B's second edge and push it back on the stack. Right? Then I pop it off the stack. Got the second edge. Let's do the third edge. Push it back on the stack. Right? Then I pop it off. I've done all of B's edges. Right? So I pop B off and I go down to now I say I've done all S's edges. Right? Yeah.
Wouldn't it make more sense to store the amount of edges initially and then decrement it down to 0 and just say when it's 0 you pop it?
Sure. I thought maybe even people do that. I don't know. I make things up as I make slides.
So what does the algorithm return?
It returns, well, we haven't really gotten there. In the original version, it returns everybody reachable and some path to it. Yeah.
So are we having another stack that is actually storing the default of the items from the stack?
No, we're gonna keep a breadcrumb. If it's circled black, then that's a breadcrumb, which means that it's fully handled. If it's circled orange, that means that it's currently on the stack. If it's circled whatever color it was circled originally, right? Here, if it's just solid yellow, then we've never found it. So those are just breadcrumbs, flags on each node. So when you go to the node, you know about it. All right? Does that make sense? Everybody kind of good? And that's depth first search. Here's the code. Right? We start with nobody's been found and handled. What's on the stack? What's on the stack is that we have found S, but we've handled 0 of its edges, right? And then what do? You pop UI off the stack, and then if U has an ith plus first edge, then what is that edge? Is going from U to V. So now we're gonna update V. So before we do that, we push UI plus 1 back on the stack, right? And then V, we're going to now deal with V. And so we're now going to look at V's breadcrumbs, right? If V has not been found previously, right? It's completely not found, then we set the tree edge so that U's parent is V, and UV is called the tree edge because that's part of these paths, right? And we push V0 onto the stack because we've handled 0 of V's edges. On the other hand, when we're looking at the breadcrumbs of U, if U has been found but not completely handled, then it's on the stack, right? That's just the breadcrumb tells us on the stack. So then UV becomes a back edge, creating a cycle, right? And then the other case is U has been completely handled, and then this edge is, I think it was purple, and it's either a forward edge or a cross edge. I don't remember the difference. All right, everybody good? Yeah? You can do it recursively. In fact, why can you do it recursively? Because you're using a stack. And at some point I have slides in which we deal with that, and I forget when. It might be now, but I think it's not until later when we're doing dynamic programming. Yeah?
Can you put like a true false value in the node and then call that the breadcrumb?
Yes. It's a flag, true, false.
Okay.
Somehow you store its status.
Okay.
Right? Yeah?
So if you have a purple edge, you just ignore it. Like move on to the next edge. Is that what you
So if you have a what edge?
If that's the purple
Yeah, the purple edges?
cross edge, so it's saying, oh, I already handled this.
Right.
So does that mean just move on to the
Yeah.
next edge? You don't
Yeah.
do anything else, right?
Yeah, here I'm just, if you want to label the edges, back edges or forward edges or cross edges, you can do that. But it doesn't really affect the algorithm.
I think you should just ignore it.
Yeah. Yeah. Everybody good? Yeah?
Can you explain how this deals with cycles?
Well, at the moment, the way it deals with cycles is when we find a back edge, when we follow U to V and V's on the stack already, then we say it's a back edge, and if you want, you could write, oh, we found a cycle, but we don't do anything. At the moment, we don't do anything with that cycle. But if you want to know exciting things about cycles, wait till the next topic. All right? Oh, here it is. I knew it was somewhere. All right, so here we're going to do it with recursion. All right, so the precondition is that you're given a graph and a start node, but there's additional things, is that some of the nodes have been marked found already, right? Those are our breadcrumbs. Our little X's are breadcrumbs. And what's the postcondition? The postcondition is to start from our source node and reach everybody that you can reach without touching a breadcrumb, right? So you're not allowed to cross breadcrumbs, and you need and reach everybody. All right. So how do we do it? So what is our job? Our job is we're given this graph starting from S, right? And what does the code do? The code says if S is standing on a breadcrumb, then you're doing bad. You're not supposed to stand on breadcrumbs. So get out as fast as you can, right? So just leave, right? Otherwise, if you're not standing on a breadcrumb, then mark it as found. Mark it as a breadcrumb. So that kind of moves us over here, and then cycle over all the edges, right? So we're now on the first edge, and what do you do with the first edge? You kind of walk down it and recurse. So here, who's our first friend? Well, this has gotten breadcrumb, our buddy, our breadcrumb here, and he got us going to search from here, right? That's our first friend. And what does our first friend do? His rule by the postcondition is search everywhere you can get without touching a breadcrumb, right? So he can't go up here, so he searches everybody here, and that's what our friend gives us back. Right? Everybody buy that? And then it's me again. So what I do is I then go down my second edge. And so I get my friend down the second edge, and I get my second friend to go. And what my second friend does is reaches everybody reachable without touching a breadcrumb. Right? And so this is what my second friend gives back. And then what I do, it's me again, so I go down to my third edge, and my third friend says, hey, I'm on a breadcrumb, so I go home. Right? And that's the entire algorithm. Right? Everybody get it?
I have a question. When we're at a node and then we want to go back, but the back node, the parent node already has a breadcrumb. So we don't really like step on.
Well, I think I was talking about going down and coming back, but that nobody actually ever travels. So let me say it again a different way with no travel. I'm standing here, and I create my friend to stand here, right? My friend from there does what he does, and then I create my friend to stand, and then it comes back to me, and I'm still standing up here. Right now, of course, I'm standing on a breadcrumb, but that's okay because I created it. It's my own breadcrumb. And then I get my friend to stand here, and my friend does that. And now I'm standing back up here, and I get my friend to stand down here. Now this friend is standing on a breadcrumb, but anybody who is born on a breadcrumb immediately dies. Right? It's the nature of being born on a breadcrumb. Everybody good?
I have another question.
Yes.
In the second friend, the node U, can he by any chance go to the right node instead of the left node? He came from the left node, but can he go up to the right node?
Which node? What are we doing?
U.
U.
Yeah, the same graph.
Second friend, you.
Oh, down here.
Yeah, so he came from the left. Is it possible to go from the right on his way up?
So if it goes
Well, first off, don't micromanage your friends, right? We're not talking about what they're doing. All we know is our second friend was born here, and he is going to make sure that all the nodes reachable are covered. So which way he goes, that's just not our business, right?
Yeah. But I mean, it would reach C from B because it's connected.
Yeah, and that's why these are all breadcrumbed.
So S didn't have to create a new friend for specifically C.
This guy does create everybody. It's all recursive. Everybody has friends. Everybody stands on their node and has friends. But we don't want to micromanage our friends. Right? Does that make sense? All right. Oh, here's just some more pictures I had from long ago.